Okay, for number 3, find the area of the region enclosed by x plus y squared equals 2 and x plus y equals 0. Since we have a y squared and a y to the first, we have x to the first in both, it's better to make these x equals a function of y as opposed to y equals a function of x like we usually do. I'm going to take x plus y squared equals 2 and transform that to say x equals 2 minus y squared. And I'm going to take x plus y equals 0 and transform that into x equals negative y. Now that I've done that, up till now kind of seems sort of like a guess and check kind of idea, kind of we're anticipating that these points of intersection will be nice and pretty. Sometimes they aren't. I think in this case they probably still are, but just in case they aren't every time, let me just consider that possibility. Since x equals this and x equals that, I can take this expression and change that x into this expression. 2 minus y squared equals what? Negative y. That's legal. You can do it that way. And that will give me points of intersection for y. Since I have functions of y, I'm thinking more of a right minus left from a low to a high point of intersection to set the integral up on this one. If I'm going to solve this quadratic structure, I'm going to move everything, I like y squared positive, so I'm going to move everything over to that side. So 0 equals y squared minus 1y minus 2. The 2 became negative, the y squared became positive. Of course, I put the 1 in front of the y because I'm assuming factoring possibilities. I like to see the numbers I'm factoring with. So 0 equals, and y minus 2 times y plus 1 works. So y is equal to 2 and negative 1. It's algebra 1 level work there, but it's been a while maybe since we've done that. So just a refresher on that. That tells me points of intersection are 2 and negative 1 on y. So if I'm setting up an xy chart like I normally do, I want to put 2 and negative 1 into my chart in the y column, and I want to figure out the x for each. But I've got two different functions here, so I'm going to make a blue x column, and I'm going to make a red x column. And I want to put these values of y into both to see what happens. So if I go to the red function x equals negative y, that just means change the sign, so negative 2 and positive 1 are the results there. If I want the blue function, 2 minus y squared, if y is 2, 2 squared is 4, 2 minus 4 is negative 2. And if y equals negative 1, negative 1 squared is 1, 2 minus 1 is 1. And you can see 1 negative 1 blue, 1 negative 1 red, negative 2 2 blue, negative 2 2 red. So the points of intersection are what we anticipated. So, and we have a 0.5 to 0.5 scale here, so negative 1, negative 2, 1, 2, there's the point of intersection on both. And then we got positive 1, negative 1 is a point of intersection on both. So my red function is a line, so I can go ahead and get a line here. Connecting those two dots, there's my red function. The blue function's a parabola, so I'd probably like to get a couple extra points there just to really reinforce what the parabola looks like. So if I pick a couple extra values of y, let's go with 0 and 1, just a couple more numbers on that range from negative 1 to 2. And we're going into the parabola, which is the blue one. If I put 0 in, 2 minus 0 squared is going to be 2, and 2 minus 1 squared is going to be 1. So 1, 2, comma 0, we get 1, comma 1, and that gives me a decent looking parabola here that looks like so. And once again, we have that anticipated right minus left from low to high structure, so we can create the integral representing that. So the area is going to be the integral from negative 1 to 2 of the rightmost function, which is 2 minus y squared, minus the leftmost function, which is negative y, and that's dy. And again, I made a y interval here, so I've made both functions about y. I'm just putting these expressions in here, the rightmost minus the leftmost function. Once again, simplification before I start evaluating, so negative 1 to 2. I'm going to get negative y squared plus y plus 2 dy. Notice this minus minus y makes the plus y. The y squared is negative, the 2 is positive. At this point I integrate. I'm going to get negative y cubed over 3 plus y squared over 2 plus 2y, going from negative 1 up to 2. If I put 2 in first, I'll come up here. Negative 2, or it'd be 2 cubed is 8, negative 8, so negative 8/3. And then if I put 2 in here, I'm going to get 4 over 2 is going to be plus 2. If I put 2 in here, I'm going to get plus 4. If I put negative 1 in, got a little mess there, but erase. Well, I can't erase. Anyway, pretend that says y cubed over 3. So if I put negative 1 in, I'm going to get negative 1 cubed is negative 1. The minus makes it positive, so I'm going to get positive 1/3. Be careful with signs. Negative 1 squared is positive 1 over 2, so plus 1/2. And negative 1 times 2 is going to be minus 2. Okay, common denominator 6, as it seems. Double makes negative 16, times 6 makes plus 12, times 6 makes plus 24. Distribute, double makes minus 2. Distribute, triple makes minus 3. Distribute, times 6 makes positive 12. So negatives, negative 21, positives makes plus 48 all over 6. So negative 21 plus 48 is 27 over 6, which reduces by 3 down to 9/2.